Hello everyone. Today we are going to talk about master production schedule, which is a very important tool of the operations management. First of all, let's see our problem. Our firm produces tables. According to the forecast, there will be demand for 200 tables during the next 4 weeks and 250 from week 5 to week 8. But customers have previously ordered 210, 80, 40, and 70 pieces for the first 4 weeks. We also know that we have an on-hand inventory of 400 tables, order policy is 200 units, and lead time is 1 week. MPS order was not made before the week 1. Let's develop an MPS. Master projection schedule is a supply plan for providing the amount of product is needed within a certain period. So, it is a plan for bringing supply and demand together. Please note that timing is really important factor in this case. Formally, master production plan is a table like the one you can see here. If we want to be really practical, we can say that filling this kind of table is master projection scheduling, but there are some very well established theoretical foundation behind it, so you shouldn't forget that this is just the problem solving section. So let's start. First of all, let's read the text and insert the useful information to the suitable cells of the table. Our firm produces table, so we can write table as a product. As you can see here, we know that forecasted demand is 200 from week 1 to week 4 and 220 from week 5 to week 8, so we can fill in the row named forecast. However, we know that customers ordered for the first 4 periods, we can fill this part as well. We also know that on-hand inventory is 400. That means we have 400 tables as a stock at the beginning of the process. Order policy contains 200 tables. So if we make an order, we will get at least 200 tables from the factory. If it is needed, we can order 2, 3 or even more series, but we will get 400, 600, etc. number of tables. Lead time is 1 week, so if we make an order this week, we will get tables on the next week. So, let's start solving the task. On the first week, forecasted demand is 200, but our customers ordered 210, so we need to be able to sell 210 tables. No problem, because we have 400 tables as inventory, so after we sell 210, our projected on-hand inventory will be 400 minus 210, that makes 190. We don't receive any tables from the factory, as we didn't make an order in the previous week. So, after we sell 210 tables, we will have 190 by the end of the first period. As the forecasted demand for second period is 200, we have to make an MPS order in the first week in order to get 200 tables by the second week. On the second week, forecasted demand is 200. Customers have previously ordered 80 tables. Demand must always meet the actual needs, so our firm must be able to sell 200 tables in this period. Let's see. We have an on-hand inventory of 190 tables, and fortunately, we ordered the cereal last week that we get by this period. So, before we sell anything, we have 190 plus 200 tables is 390. After we sell that 200, our projected inventory will consist of 390 minus 200, that makes 190. We have already discussed that the tables we ordered last week were produced by this period. That's why we have 390 before selling 200. As there is a demand for 200 tables on week 3, and we have only 190 at the end of the week 2, we have to order one cereal this week as well. At the beginning of week 3, we will get 200 tables from the factory as the order of previous week arrives. There is a demand for 200 tables. We have on-hand inventory of 190 from the previous week. So at the beginning of this period, we have 390. We sell 200 items. There remains 190 as on-hand inventory. As there is a demand for 200 tables on week 4, and we have only 190 in the stores, we have to make an order for one cereal in order to get another 200 tables for the next week. At the beginning of week 4, we get 200 tables from the factory, and we have 190 in our stores, so we have 390 again. We sell 200, so there remains 190 on-hand inventory as usually. But things change a little bit as demand grows to 250 for the 5th week. We have 190 at the end of this week, and if we order one cereal, we will have 290 again. That must be far enough, so we shall order just one cereal in this period as well. At the beginning of 5th period, we get 200 tables from the assembly department together with the on-hand inventory from the last week. We have 390 tables again. If we sell 250, the projected on-hand inventory changes to 140. Forecasted demand is 250 for the 6th week. We have to make an order for one cereal again. 200 tables arrive by the beginning of the 6th week. We have 140 from the previous period. It is 340 at the beginning of the week. If we sell 250, on-hand inventory reduces to 90. Forecasts suggest that there is a demand for 250 tables on the 7th week, so an MPS order must be scheduled. We get 200 tables from the assembly for the 7th period, and we still have 90 from the last week. If we set 250, on-hand inventory will be as little as 40. There is a demand for 250 on the last week, so if we order 200 tables, there would be a lack of tables by the last period. Consequently, we must schedule an order for 2 series that contains 400 tables. 400 tables arrive by the beginning of the last period, so we will have 440 before any transactions are made. After selling 250, on-hand inventory will be 190 again. It doesn't mean a problem, because our purpose here is not to minimize inventory, but ensuring appropriate supply for existing demand. Furthermore, we don't need to schedule MPS order as last period and our task is ended. Thank you